Hi everyone, our final year project is the video, voice, and text-enabled chatbot to support people with aphasia. Now let's walk through our project. Let me give a brief introduction to aphasia. Aphasia is a neurological disorder caused due to strokes or brain injuries. This causes people to have communication disabilities like speaking, understanding, spoken language, reading, and writing. Many people around the world suffer due to aphasia and other communication disabilities. Currently, about 250,000 Australians and over 2 million people in the USA suffer from aphasia and other similar language disorders. A considerably higher amount of people who get strokes have to face aphasia as a result of the stroke. Next, let's talk about the problem and how we solve it. With the communication disabilities we discussed before, people with aphasia face difficulties in using a website. They are unable to comprehend and find the necessary resources as a general user. Usually, they use gestures, speech, facial expressions, and writing to communicate what they want. There are no applications that support people with such difficulties to easily navigate and find resources within a website with these multimodal capabilities. We have developed a multimodal chatbot which is unique and specifically designed for people with aphasia. It would get inputs from multiple modalities like audio, text, video, and clicks. The inputs would be classified into intents based on the user inputs. Then these multiple intents would be fused to get the exact navigation or navigations. The chatbot will be used for navigational support, and also it will have support for multimodal inputs. The navigation would happen based on the keywords associated with each URL. This helps people with aphasia to easily navigate within a WordPress website, and it is developed as a WordPress plugin. To give a brief overview of the related work we have gone through so far, there are chatbots that offer support for multiple modalities such as ZatKit, Multimodal GPT, Angera, and others designed for mental health such as Bungie. However, these chatbots don't provide the functionality to understand the unique speech patterns and communication needs of individuals with aphasia, so they are not capable of providing support for aphasia or other language disordered people. If we get a glimpse of the technical overview of the development of this multimodal chatbot, we can mainly identify three main sections as taking inputs and processing, intent classifier, fusion and output generation. Since our chatbot is a navigational chatbot that supports multiple modalities, we take in 4 types of inputs: text, audio, video, and clicks. The text input is taken from the chatbot interface, and the audio and video inputs are taken by requesting access to the web camera and microphone of the device used to access the website. The click and the gesture inputs are used when we provide multiple navigational paths for the user to select. For the audio transcription, we have used the Whispers-based model as it performed the best based on the word error rates calculated for aphasic voice recordings. For gesture recognition, we have used the Media Pipe Gesture Recognizer to recognize the landmarks of the hand, which would then be used to detect the hand gesture of a number representation of 1 to 10 using a neural network. Here, a neural network is trained using a dataset that we created using hand gestures from individuals. Then both the transcribed audio and the text input would be sent for vectorization through the vector converter. We are using the Distaloose-based multilingual cased V2 sentence transformer for vector conversion of the inputs. A vector database is also used, including a keyword URL mapping for each navigated URL that would be vectorized using the same sentence transformer. The vectorized inputs and the vector embeddings in the vector database would be compared using cosine similarity to get the most matching navigations. In the fusion model, the matching navigation from all the modalities would be combined to get the final output URLs. Here, the fusion component will give 3 types of outputs: doing a direct navigation for a web page, showing multiple navigational options for the user, showing no navigational response as the input did not match with the resources in the website. Experimental thresholds are used for these selections. Using these outputs, the dialog manager would be giving the final output customized for the user's input. To summarize the technologies used within the application. The application is built as a WordPress plugin, where this can be used for any WordPress website. The backend is implemented using Flask, and the front-end back-end communication happens through WebSockets. The transcription model, gesture recognition model, and intent classifier are containerized through Docker and called from the Flask backend for each functionality using Fast API. That wraps up the technical overview, and let's dive into the demonstration. This is the website that we have created to demonstrate our chatbot's capabilities. Our chatbot will be able to use multiple modalities to navigate within this website. This is our chatbot. It can use text and audio to input a message. The gestures and click inputs are used when there is a list of navigations displayed. We can start off with a greeting message.
Hi. I'm here to assist you.
The chatbot responded with text and audio as well. Next, let's see what happens when I type something like, "Show me related disorders," using the text prompt.
We are redirecting you to related disorders page.
I get navigated directly to the related disorders page. Next, I will say something like, "I need therapy," and let's see what happens.
I need therapy.
Pages I found are 1 Aphasia apps, 2 therapy, 3 impairment-based constraint-induced therapy, 4 Apraxia therapy, 5 impairment-based therapies.
I get a list of navigations that the chatbot suggests. The user can use click input or gestures to navigate to the relevant page. I will first use click input to navigate. Next, let's see what happens when I type, "I have aphasia, I need help."
Pages I found are 1 cause of aphasia, 2 language therapy, 4 in 1, 3 communication problems, 4 recovering with aphasia, 5 incidents of aphasia.
I will again get a list of navigation suggestions. This time I will try to use gestures to navigate. For example, if I want to go to the second one in the list, language therapy 4 in 1, I can gesture number 2 as follows, and it will navigate me to the relevant page. The user can also use both text and audio at the same time as well. For example, let's see what happens when I type, "I want a break," and say, "I need to relax."
I need to relax.
Pages I found are 1 leisure and recreational activities, 2 visual coping techniques, 3 therapeutic intervention for depression.
The chatbot will give me the fused intent of the text and audio as the navigation. This demo presented you with our text, audio, and video supported multimodal chatbot's capabilities. And that concludes our demo. Thank you for watching. We hope you found it informative and engaging.